Good morning, students. Now, today we are going to start our next chapter, the new chapter, that is chapter number 11, Ray Optics. Chapter number 11 and chapter number 12 has combined one unit that is known as optics. Okay, and in chapter number 11, it is about the ray optics, and chapter number 12 is about the wave optics. Okay, so chapter number 11, it just we can say the it can completely depends on the chapter which you have studied in the in your 10th standard about light. Okay, what are mirror, lenses, concave, convex, lens formula, mirror formula, magnification, then human eye, okay, the reflection, refraction. Okay, so all these things which you have studied in your 10th standard that have been come in this chapter in the advanced version. That's why I am taking this chapter, and afterward the wave optics we are discuss in when we are physically present in the school, chapter number 12, because that was the important chapter, and this one is also be the important one, but you can understand this chapter easily because you have the basic ideas of this chapter from your 10th standard. But chapter number 12 may be a little bit difficult for you because in that the entire derivation portion is there. Okay, so I hope that if the school will physically open, then we will discuss that chapter in the school only. Otherwise the same we are doing as other chapter, we will do it in the online classes also as well. Okay, but first this is the lengthy chapter, chapter number 11 and chapter number 12, both are the lengthy chapter. Okay, and from today we have started our part 2nd of the physics book. Okay, part 2nd we have started. In part 1st only 10 chapters are there that we have completed. So our first part of physics has been completed, first book. Now second part is there are 7 chapters. Okay, chapter number 11, chapter number 12 is about the optics, that is ray optics and wave optics. Afterwards the dual nature of a light, the wave, matter, okay, that we are going to discuss, and atomic physics, nuclear physics, and afterwards the semiconductor and electronics, and last but not the least, the last chapter is about the communication and electromagnetic waves. Okay, so these 7 chapters are remaining, but chapter number 11 and chapter number 12 is to lengthy chapter. So first we are going to start with chapter number 11. It's a very lengthy chapter, okay, but it is such an easy chapter because the entire basic concept you know it very well. If you don't know, then also I am just explaining you the entire things. Okay, so starting with this chapter, what is light? First of all we have to discuss about what is light, beta. You know light is a form of a energy, okay, and with the help of this only we are able to see the objects, because light has been fall on them, okay, then we are only able to see the object. And it was always a matter of a curiosity to know about the production and nature of a light and the related phenomena. Okay, so from our common experience we had understand that from 10th chapter even we know that, from 10th class we have know that the light is always travel in a straight line and its speed is extremely high. You know the speed of a light, beta. Okay, 3 into 10 to the power 8 meter per second. So the light has just been travel in a straight path, okay, and that has just been known as ray. Okay, so I am just writing one definition, that first point in this is the straight path traversed by light is called a ray. And even this ray has been denoted by a straight line with an arrow. You know it very well. Okay, and second one is the group of ray is called a beam. Group of a ray is called a beam. Okay, so there are some optical phenomena, that is reflection, refraction, dispersion, atmospheric refraction. We have just be understand in this chapter by using the concept of light. Okay, clear? Then afterwards we will discuss in this chapter about the optical instrument like telescope and microscope. Okay, so let's start with our chapter, and the first topic is such a common topic and you know about this, that is reflection of light. Reflection of light. Now what is reflection of light, beta? You know, beta, when the light has been traveling in a same medium, then it will be bounces back at the boundary, and this phenomena is your reflection. Okay, so the light traveling in a medium returns back at the boundary this phenomena is called reflection. This phenomena is called, beta, reflection. So for more understanding, you can easily understand with the ray diagram of its. Okay, from this diagram it has been clear, more clear. Okay, like such that we have just checked, this is the a plane, a smooth surface, one of its side is polished. Okay, so other than the polished side, this side is your reflecting surface. Suppose that the ray of light is coming, okay, and it has been incident on this point, and afterwards it will be reflect back. So there is a one line which is perpendicular to the incident point where it has been incident. Okay, so I am denoting all the names. This one is your incident ray. Which ray, beta? Incident ray. The point where it incident on the reflected surface is your incident point. After this it has been reflected, so this is your reflected ray, and the line of a normal is your normal ray. Okay, the incident ray makes an angle with the normal ray, that is angle I, angle of incidence. The reflected ray makes an angle with the normal ray, that is your angle R, angle of reflection. Okay, and this is your reflecting surface, a plane surface, reflecting plane surface. Why I am here indicating the plane surface? Because surfaces are of a two type, a regular surface, okay, a plane surface and a rough surface. If the light rays has been incident on a plane surface, then we are having the angle I is equals to angle R, a perfect reflection ray, reflected ray we get. But if the light ray has been incident on a rough surface, then we are having a irregular reflection. Okay, irregular reflection, even the laws of reflection is also be not followed in the irregular reflection. Okay, so what are the laws of reflection? First laws of reflection is the angle of incidence is always equals to the angle of reflection, means angle I is equals to angle R. Second one is that the incident ray, reflected ray and the normal on the reflecting surface lies on the same plane. We have seen that beta, incident ray is coming at point O, reflected ray is also be at point O, they are meeting, normal ray is also be at point O, and this point O is the same plane. Which plane beta? Plane surface, a reflecting plane surface. So we can say incident ray, reflected ray and normal at the point of incidence is always lies on the same plane. Okay, that is with the plane is known as the plane of incidence. Clear beta? So these are the two laws of reflection. Now we are going to write these laws. The subtopic is laws of reflection. So the first one is the angle of incidence, that is angle I, is equal to the angle of reflection, that is angle R. So we can say angle I is equals to angle R. Okay. Second one, the incident ray reflected ray and the normal on reflecting surface lies in the same plane, that called plane of incidence. Okay, clear? So these are the laws of reflection, and even you know about the laws of reflection. Okay, and in the reflection there is no any change in the frequency and the wavelength of light. Okay, if the surface absorb the light, then the intensity of the reflected light decreases. Okay, so I am just writing this thing in a note form. So sometime it has been asked in the form of 1 mark question, then you are able to write the answer. That is, in reflection there is no change in frequency and wavelength of light if surface absorb light, then intensity of reflected light decreases. Okay, clear? Means if the light has been absorbed by the surface, then the intensity of the light has been decreases. It's obvious beta, because the as much as the intensity is, of a light has been traveling, so the light has been absorbed by the surface, then somehow the intensity is also be absorbed by the surface and the intensity of a light has been decreases. Clear? Now we are going to understand about the formation of the image by a plane mirror. So the next topic is formation of image by a plane mirror. Okay, so in this I am just drawing the diagram, and the theory you have to be write by your own. Okay, so how does the image has been formed? I am just drawing the diagram. Suppose this is the plane mirror A B. Okay, this is the surface, another side has been polished. Okay, clear beta? Now I am just consider a point object at P. At P I am just considering a point object. Okay, and this is just be in front of the plane mirror AB. Okay, now always for the construction we need two rays. Okay, so the two rays are here. First is coming and another one is from here. Okay, these are the two rays. So this one is your PQ and this one is PQ dash. Okay, clear? Now these two rays PQ and PQ dash has just get reflected by the mirror. Okay, and they are just becoming that they are just be reflecting. Here I am just drawing one normal, so it will be easy for you. So they are just reflecting. So these are the reflected ray. This PQ has been reflected by R and this one PQ dash has been reflected by R dash. Okay, they are reflected back. Now this is the mirror. Suppose N dash is your mirror. Okay, now if they are reflected back, then they are just be diverges from each other, so they will never be meet in the end, and the image is always be meet where the reflected ray has been meet. So what we have to do, we have to be extend the line in a backward direction. So from here they are reflected back, so from here we are just be extending them back, and here our image has been formed. Okay, you have been just been drawn with the help of this scale, so the perfect image will be formed. So this is the image of P dash, because here they have been meet. Clear? So here is our eye. from here we are just be able to see the object. Okay, so here our image is there. So these rays has been reflected and seems to be coming from the P dash. Now the P dash, okay, what is this beta? P is the object, P dash is the image of the object, and the image is virtual, erect and laterally inverted. Okay, clear? So what is this beta in this? This is the object, this has been the image of the object, and this image is beta what? Erect, straight and virtual. And what is else? A laterally inversion. A laterally inverted means the left seems to be right and right seems to be left. And the common example of this lateral inversion is the ambulance, which has been written in the ambulance van. Okay, so that has been example of the lateral inversion. Okay, so theory of this you have to be write by your own. Okay, I hope that you are able to understand the concept of it. In this, you have remember that the size of the object of the plane mirror and the size of the image formed by the plane mirror are equal, are same. And second thing is that the distance of the object from the mirror is always be equal, sorry, the distance of the image from the mirror is always be equal to the distance of the object from the mirror. The size will be the same, the length will be the same, the distance will be the same, the height will be the same. The image is just be a copy of the object formed by the plane mirror, but the one thing that is, it is laterally inverted. It is laterally inversion is there. Laterally inversion means the left seems to be right and the right seems to be left. Means your right hand has seen as a left hand in the plane mirror, and your left hand is just be seems as a right hand in the plane mirror. Okay, so this is a formation of the image by a plane mirror, and the theory of this you have to be write by your own. I have explained the ray diagram, the image formation of this, okay, an entire thing as well. So you have to be write the theory by your own. Clear beta? Now from tomorrow we are going to start with the spherical mirror, okay, and all the things about the spherical mirror as well. Clear beta? Okay, thank you, that's all for today.